I'm going to show you how to make a Pythagorean Theorem equation solver in LabVIEW. So we have the equation for the Pythagorean Theorem, which most of you probably already know, or you're learning it right now in middle school. So what it basically is the equation that you use to find the hypotenuse of a right triangle. So you have the A side, the B side, and the C side is the hypotenuse. Now, what the equation tells you is that you have A squared, which here, right here, means that you square the side that A is, so it creates a square with one edge being side A of that right triangle. B squared does the same thing. You draw a square off to the side of that side of the right triangle, side B. That creates a square. A squared plus B squared means that the sum of the A square, plus the B square should equal the C square. And that's what you get from the equation. A squared plus B squared equals C squared. So, we're going to make a little program in LabVIEW that we can use to solve the Pythagorean Theorem. For any side that we put in, we're going to solve it for C. So, we go to our numeric controls, have a little control right there, let's call it A. Okay? Then we have a second one, a second numeric control, let's call it B. Okay? B. Then we have two controls because we have two sides that we know of the triangle, but we want to try to figure out the side C, the hypotenuse of the right triangle. So we're going to need a numeric indicator, which you can use a digital display, or you can use a gauge or a tank or anything you want. The numeric display makes more sense for this type of situation. So what you're going to do is you're going to call this one C. These are your inputs. That's your output. Controls, indicator. Alright? And then over here on the block diagram is where you're going to put your functions that will actually make the Pythagorean Theorem equation solver work. So, you're going to right click, you're going to go down to arithmetic, go to numeric, and since we have A squared, we're going to click on the squared function. And then we're going to wire the A side that we know to that. Alright, then we're going to right click again because we also have B squared. So we have B squared, we wire it to that. And since we have A squared plus B squared, we need the addition function, which we're going to wire A and B to. A squared plus B squared. Then, since we'll get A squared plus B squared, well, that's fine and everything, but the problem is we don't want the side C squared, we just want the length of C of the right triangle, the length of the hypotenuse. So what we're going to do is, when you have C squared, what you can do to get rid of that square is you can use numeric. You can take the square root of it. The square root of C squared equals C. Just like you can have the square root of C, and if you square a square root, it'll get rid of the square root. That's how it works. So then what you're going to do is you're going to have the square root of A squared plus B squared equals C, which will be that side. Alright? And then what we can do over here is, okay, let's run the program, and let's throw in side A, 3. Alright, then side 4, and you get 5. 3 squared is 9, plus 4 squared is 16. That's 25. Now that would be the value that you get if you had C squared, but since we're taking the square root of 25, we end up with C equals 5. And if A were 3 and B were 4, C would equal 5. And that's how the LabVIEW program for the Pythagorean Theorem equation works.